Alright, hey folks, so this is kind of like probably the last video of the whole series, which is Anatomy of Campus Fabric. If you have not checked out the rest of the videos, please go and do check them out, because you'll get a full context of what we are doing here. But just to summarize what we have done, we have set up the underlay. We have kind of set up the overlay as well with all the Lisp VXLAN, the macro segmentation, the intra-VM communication was achieved. We saw the mobility as well. Then we set up the policy plane with the SGTs, and in the Fusion we have done the whole BGP peerings. Then we went about connecting our VNs to the external world, right? We connected our sales and the IT VN to to the enterprise data center, and also to the outside world, that is basically outside internet. So in this video, what we'll do is we'll do the last two sections, which is here. We will establish connectivity. We'll do inter-VM communication, right? If that is the use case your organization needs, right, you can establish that as well, and we will look into how we can do that. So inter-VM communication, which means the IT host will be able to talk to the sales host. And finally, we'll also talk about how the campus fabric handles DHCP, right, in the network, right? So with that context in mind, let's proceed. Okay, we are done with the first part here, which is connecting to the enterprise data center or the outside, right, from our clients. So our clients are now able to, irrespective they are in VRF sales or say IT, or even from the global routing table, right, our APs, all of them are able to talk to the internet, and depending on our rules, they are able to talk to the data center, and all of that connectivity has been verified, right? Next is we'll check inter-VM communication, right? Now technically, maybe this is something, ideally you would not want this feature, right? You wouldn't want your IT folks to be able to talk to sales, right? But in case if you have some use case where you want one VRF to talk to other VRF, right, in that case, it is possible. I mean, technically it doesn't really make sense to do all this isolation, put in the effort, and finally go and leak the routes, right? But it might be a case that if you see in my VRF, I just have one subnet in each of the VRF. I'm using 172.16.10.0 and 20.0, right? But you might have a network where you have multiple subnets in a particular VRF, in which case you would want to share probably one of the subnet between both. Maybe you want to share one subnet from the IT to the sales, and you also want to share another subnet from sales to IT or whatever, right? So inter-VM communication comes into play here, right? So for inter-VM communication, you can't do anything inside the fabric. The traffic has to travel all the way till the Fusion, and you have to leak it over here, or do that leaking between the VRF, right? Till now what we did was we did the leaking between the global routing table of the Fusion with the VRFs. Now we are going to do leaking between the VRFs itself, right? Because we want the IT to talk to sales. And let's check how we can do that. Pretty simple actually, I would say. So first, before doing that, let's go and check what we have. So let's go to probably the Fusion, right? Let's clear the screen a bit. So let's say show IP BGP VPN v4 VRF IT, right? That's one of the VRF. The other one is the sales. This is what we have right now. You see the 172.16 in my IT, I have 172.16.10.0, and in my sales I have this subnet 20.0. But what I want to do is I want to send this 20.0 up here, and I also want to send the 10.0 down here, so that they both will be able to talk to each other, right? And this one you're going to do using route targets, right? Very simple. So what we'll do is, let's go to the route target, which is let's go to the VRFs. Let's look at the VRFs once. Show run I don't know, maybe VRF IT, and let's also look at the other one, which is the VRF sales. Okay, so probably that's good. So let's go inside first. Probably let's do sales if you want. Let's go inside sales, right? So inside this, what we are going to do is we're going to say we have, where is the route? We have the route target export and import set to 4100, but we want the routes from where? We want the routes from the other side. So we are going to do route target import, right? But this time we are going to import not just 4101 but also 4100. So now we are getting all the routes from where? From IT inside sales. Same thing we have to do for IT as well. So let's go inside that guy. So this is inside IT, we are going inside IT, but now we are going to say route target import. This guy by default is importing 4100. Now we are going to import 4101. Sweet. Let's look at the routing table if it has changed, right? So show IP BGP VRF IT. So in the IT, now you can see along with the, okay, has it come? I still see 10. Give me 1 sec. Okay, it just took a few seconds. You see here, here it was not coming yet, but I think it just took few seconds. So inside IT we had the 10, but now you see along with the 10.0 we also see the 20.0. Similarly, if I change this to sales, we should see the 10.0 as well. There you go, right? So now we have leaked the routes from we are basically leaked the VRFs as well, right? The sales VRF into IT and IT into sales. What does this mean? This means earlier, you know, we were not able to talk between the VRFs, right? But now we should be able to do that, right? So let's try that. So let's go to host 1. Let's clear the screen a bit. So let's just first do intra-VN once again, just to check if everything is working. 172.16.10.11. This is still intra-VN. I'm just talking to another host in IT itself. But now, instead of 10.11, let's say 20.10. So which is this? This host is nothing but sales host. It is one of the sales hosts. Let's go back to our diagram. I'm trying to ping from IT host 1 to this guy, right? To sales host 2, which is in a different VRF, which is 20. Let's do 20.10. Yeah, correct. Let's check if this works. Yeah, there you go. It worked, right? So awesome. So we are able to now talk to. Let's also try if we can ping the sales host, which is in on a different switch, which is sales host 4, right? Let's try that. So how do we ping that guy? Let's change this to 11, 20.11. There you go. It went in. Let's try once again. Yeah, right. So now we have successfully done Inter-VRF communication as well, right? So now we are able to go from IT host to the sales as well. Earlier it was not happening, but now that we have leaked the VRF routes, right, over here on the Fusion, the traffic will go all the way up till the Fusion. It gets leaked because we have leaked over there, right? You are able to now, you know, the traffic comes back from the border. You are able to send it to anyone down south as well. Right? Let's look at if something has changed on the borders, right? This is something might be useful if there is something interesting here, right? Show IP route VRF IT, right? Here you see it's still 10.0. You don't see 20. So that is what, you know, that's why I've been telling the traffic, you know, you don't do any leaking on the border, rather you do it on the Fusion. So you know, traffic will, because of the default gate, will go till the border, it will go till the Fusion, and once it comes to the Fusion, here the, you know, routing to a different subnet happens, and then it comes back, and from there, you know, it goes to the different you know, destinations, right? Different VRFs. All right, guys, so we have done that as well. So the last part is we want to discuss is this DHCP stuff. Now the disclaimer here is that we will not be able to do this. I mean, the demo, it is obviously not going to work exactly, because one of the main important feature which is needed for the DHCP to work, right, is DHCP snooping, the option 82, but that doesn't work very properly in the CSR100v which we have here. Or maybe I probably am doing something wrong. If you guys figured it out, probably drop it in the comments. Would be good for me to learn as well. But nevertheless, let's talk about DHCP, and like I said, going back to our config guide, everything is here in the config guide. You don't have to scramble anywhere else. You see there is a section called configure DHCP in Campus Fabric, right? So that is pretty detailed as well. So we'll just quickly discuss about this, and then we'll close this session. All right, so let me clear the screen a bit here for DHCP. Right, so for DHCP, all right, so for DHCP, let's go about let's do all the configurations, and then I'll kind of point out certain things which are not going to work, you know, in our setup. So, but then, you know, it's going to be a good discussion, right? So let's start. So these are basically the steps of configuration, and then we'll discuss the whole process as well. So we need to have a loopback 0 on the fabric edge. Let's check that out. So we are on the edge, right? Let's do this all on the edge 1. Clear the screen, right? So let's see. So we have show run interface loopback 0, right? We've got the loopback ready, so that's good. The next thing is we need to have the fabric edge configured as a proxy ITR, and we need to have a map cache request, which is basically the 0/0 request to be manually added, right? So let's do that. Let's see what we have as of now, and so that we can change it. Show run section Lisp. Okay, so that's mainly what we have. So let's go and fix it. So we'll say conf t, let's go inside router Lisp, right? Let's go inside service IPv4. Now here we need to put in the we need to put in what? We need to put in the map cache. So let's dump this command, because this will you know, automatically create a 0.0, you know, or /0 entry in our map cache table, right? So map, okay, that command is not working. Interesting. Sorry, okay, I think I missed this one. So we will have to go inside the VRF. My bad. Okay, let's do that. Don't we already have it? Let me double check it once again. I thought we had it, probably not. So this is IPv4. Oh, it's there, already there. Okay, see, there you go. We already have the map cache command, right, inside the VRF. This is the VRF. This is the VRF IT, and look, we already have the command already in our this thing. So the other thing is, so that's one thing. And the proxy ETR, we have already configured the proxy ETR. Remember, we have configured it up top here, so that it gets inherited. You know, proxy ITR is already configured, so that's good. What else? Enable DHCP snooping. So this is really not possible. So I mean, I think one of this command we could do it. I think the first command works, so let's try that. Okay, so that works. The enabling option 82, I mean, enabling option, basically what we are trying to do is we are trying to tell the edge device to send the option 82, you know, add it to the payload and send. But it also, the guide tells that we need to enable DHCP snooping. And the problem is we can't really enable DHCP snooping globally or per VLAN as well on a CSR100v. So that's kind of like a limitation. And I think because of that, I was not able to get this working. So you see here, there is nothing, there is no snooping command at all, right? So you probably can't enable snooping here in you know, the CSR100v. But anyway, so apart from this, we can configure rest everything. So let's just park this for now. Let's go to the next part. So we need to have, obviously we need to configure the IP helper address, right? So we need to configure the IP helper address, where we'll have to do this in our bridge domains. So let me show you where, right? So we have these bridge domains, right? These are our SVIs. So we'll have to configure here. So let's see, what do we have, right? Do show run interface. Let's do bridge domain interface 10, right? So let's go here. Right now you see there is no helper address, so let's configure that. So let's go inside, okay, so let's go inside BDI 10, and we are going to put the IP helper address, and we are going to put the helper address, DHCP address of our DHCP server, which is 172.16.255.10. Sweet. So that is done. What else? Let's go to the next step. Then configure the host facing on the fabric. Yeah, so we have already configured our host to enable, we have already configured that guy to DHCP, right? So that should be fine. We have already put it in the VLAN and all of this, so there's nothing needed to be done on here. And on the fabric border, configure the fabric border, you know, which is also the map server router that connects. So this is basically your border configuration. There is nothing new. We have already configured this. The only thing is, remember, we need to so let's see, is there anything extra? Nothing else. So this is, I mean, this is something which we have already configured. This also is there. So this is all good. Okay, so only this part, right? This is what I was telling. This is the reason why we created those dummy loopbacks, right? Remember on the border, I told you we'll talk about this when we discuss DHCP. So this is the time, right? Show run or show IP interface brief. Remember, we created this dummy loopbacks over here, right? These are the 3 loopbacks which we created. This was for the loopback for the subnet, which is the infra VLAN, and this was for which one? The IT VRF, and this is the Anycast gateway for the sales VRF, right? So we created these 3 dummy loopbacks here, right? And we kind of advertised it in the BGP, right? Like this, in this way. We did this already when we configured the Fusion router, and this is very much needed because without this the DHCP won't work. So when I show you the whole packet walk, I'll tell you the significance of this, right? And the last piece is obviously configuring the DHCP server as is. Let me show you if that is configured. If not, we can configure that as well. So let me grab that. Where is it? So this is my DHCP server. Let me show you the DHCP server's configs, right? So let's do show run section DHCP, right? There you go. So I have excluded the default gateway obviously, and I have configured the pool, and I've also provided the default gateway, right? So that is all done. Now what I'll do is let me just do a no shut of the interface so that we can see what is happening, right? What kind of a packet is received and all of that. So let's go back here. Let's go to my IT host 1, right? And let's enable DHCP here. Let's say configure interface Ethernet 0/0 and do a no shut, right? We have already enabled DHCP on this guy. So the DHCP messages should start going, and I'm already doing a capture here. So the messages should start coming here anytime. Okay, yeah, there you go, right? The DHCP message came. Okay, looks good. So you can see the DHCP message is coming here, and you can see the DHCP discover is going in. So I'm doing this capture. I believe I'm doing it here, at the gigabit 4 interface. I think I'm doing it over there. And you can see the DHCP discover is coming, right? The discover is coming from where? Let's see, where is the discover message? Let's pick a discover message. See, discover is coming from 172.16.10.1. It is coming from our from the edge 1, right? You can see the discovers coming in, and my DHCP server is responding with the DHCP offer as well. But then the packet is getting dropped, right? So if you see here, there are a few important things to be noted down. So the first thing is, let me just write it down. I think it's easier. The first thing is we need to let's grab that. Okay. First thing is we need if you see the DHCP discover packet, right? The source address of the packet is always 0.0.0. Why? Because we don't have the IP address yet, right? The host 1 doesn't have the IP address. So that is why the source IP of that packet discover is 0.0.0, right? We can actually verify that. Let's look at one of the discover packet. Let's go to discover, and it's going to be probably, yeah, in the DHCP part here, it's probably going to have, give me a second. All right, so I pulled out one more capture because I was earlier capturing it over here, right? So yeah, you would basically see all the encapsulated stuff over there. So I pulled out a capture here from the host directly, and you can see the discover packet very nicely here. You can see the source address is 0.0.0, right? Which is very much in line with what I was telling. Now the problem here is because the packet is source address is 0.0.0, the edge 1, which when it receives this packet, right, it and if you configure the edge to be just if you configure the edge fabric edge to be an ITR, right, one of the important rule of Lisp fails, right? What is the rule of the Lisp? This very important rule of Lisp states that any packet which is coming, if it has to be forwarded by the Lisp, right, if it has to be forwarded by the Lisp forwarding table, then the source address should be one of the EID, one of the address from the EID table, right? Now this fabric edge will have which EID table? It will have EID table for 172.16. I mean, literally it will not have any EIDs when it starts with, because there would have been no, but imagine for a minute that, there are few other clients, which have already gotten its IP address. So it is going to have a EID table with 172.16.10.0 from this subnet, right? There won't be any other subnet at all, right? So the fabric edge, right, will forward the packet using the list forwarding table only if the source address is from the EID table. But now since my DHCP discover is having a source address of 0.0, right, this guy will drop it. So that is why we configure the fabric edge to be a proxy ITR, right? If you configure it to be a proxy ITR, then this particular rule, which I just now told you guys, is kind of bypassed. So this ITR rule is no longer valid, and you configure it to be a proxy ITR. That is why in our edge, we have configured it to be a proxy ITR. So that is step number 1. That is something which you need to know. Second thing is, what is this option 82 stuff, right? What is option 82? Let me show you in the one of the packets, right? If you see any of this discover packets, when it is going to the this is the packet, this is the discover packet, which is kind of like which is coming somewhere here, right? Which is somewhere over here. So it is the packet which is coming after the edge has seen the packet. So what it is going to do is the edge is going to add certain things to the payload, and that is called option 82. So you see here at the bottom you have a lot of options. So if you scroll down here, you have two important entries here, right? You are going to have what we call as this option remote ID, right? So, and this is what you get. So if you decode this, right, this is basically in hex, but if you decode this section, which is AC10 0A and 01, if you decode that, you will get basically something like 172.16.10.1, right? Ideally, that shouldn't be the case. So I think, I have a feeling, because DHCP snooping is not enabled, that's why the incorrect option value is going. But what is intended is, when option 82 is enabled, why is this option 82 getting enabled? So let me just explain this. So what is happening is, so we have our border here and we have our fabric edge, right? Similarly, we have other fabric edges as well. Right now, the DHCP request, the DHCP request or the discover has gone from here to here. The border has sent it to the fusion, right? The fusion is here, and the fusion has sent it to the actual DHCP server. The DHCP server has replied back with the DHCP offer. The DHCP offer has come to the border, but the border, where will the border, how will the border know where to send this packet, right? Because when the DHCP discover was sent, it would have been sent with the source address of 172.16.10.1, which is the Anycast gateway. The same gateway is going to be there here also, 172.16.10.1, right? Let's just double verify that, right? If you look at my packets here, look, it's 172.16.10.1, right? Now the problem is, this particular gateway is there on all the fabric edges. So how will the border know which fabric edge to send it to? So to solve this problem, right, this is a very interesting thing which in Campus Fabric, they have introduced. They introduced the concept of option 82. So in option 82, what you do is, to this DHCP packet which goes up, right, you add some extra information, and that extra information is nothing about, you add the rlock or the source rlock. What is the source rlock here? 10.0.0.11. This is unique, right? This guy's source rlock will be 10.0.0.12. So if the packet is coming from here, this fabric edge will add this particular extra information and send it to the border, and that information is going to the fusion. The DHCP server will not tamper with the option 82 information. It will retain it as is, and it is going to send it back, right? So now the border, when the packet comes here, the border will know that this one has to be forwarded to this fabric edge and not to this guy, because of this extra information which was added, right? So that is very important. So to have this this particular information in that option 82 is very important. So that is the second thing, right? So what we discussed, first is about what is that? Let me just grab that. Okay, first is about the proxy ITR. Second is about option 82, and the third one is the loopback, right? The dummy loopbacks. Now, why are these dummy loopbacks created on the border, right? So what happens is, if you go back to that earlier diagram which I was telling, right? So when the packet is coming from, this is the fusion, this is the border, and we discussed this earlier, right? We have the DHCP discover going like this, and the DHCP offer is coming back, right? You have the DHCP server here. So when the DHCP offer comes back here, the problem is, initially assume at t is equal to 0, right? You will not have any clients at all, right? Your full Lisp domain will be equal to 0, right? You won't have any clients in your Lisp at all. So as a result, we remember the inside BGP we have redistributed Lisp, right? We have done that earlier, but this will not have any effect because the Lisp database will be completely 0, because it's like a chicken and the egg problem, right? Because for the Lisp redistribution into BGP to work, we really need something inside Lisp, right? But currently there is nothing because none of the EIDs have yet received any DHCP address, right? So for that reason, when the border sees this packet coming for what, 172.16.10.1, right? Border is going to drop the packet because there is no IP address or there is nothing in the routing table of border to accept this particular packet. So that's why we create a dummy loopback, right, on the border to kind of punt that particular packet to the Lisp process, right? Once it sees this loopback, right, the border will obviously not drop the packet. Instead, it will be punted to the Lisp process, and from there, the packet can then be sent down to the Lisp domain, and the actual DHCP offer can be sent correctly downwards, right? So that is the reason these three things are very much important, right? So hope that is clear. So now, like I said, the problem in CSV 1000 in the routers which we are playing around, right, we really don't have we really can't create the DHCP snooping. So I believe because of that we can't configure DHCP snooping, and as a result of that, what I have observed is the option 82 information which is going, it is incorrect, right? I would ideally want option 82 to be, the information to be 10.00.11 to be sent, but looks like the option 82 is sending the incorrect information, and I think that's mainly because the DHCP snooping is not enabled, right? So if you guys, any one of you were able to get this working, do let me know in the comments. It will be pretty cool, right? Cool. Anyway, so we are anyway not using DHCP in our lab. We have manually configured it everywhere, right? So that was a quick thing which I wanted to put it out there. Like I said, everything is very nicely detailed in this particular config guide, right? With a very nice diagram and stuff, right? Whatever I explained, everything is right from here. You can see here the whole path. So the DHCP discovery from the client to the relay agent, which is nothing but the fabric edge, and from there you see the option 82 information gets added and it gets sent to the border. The border will forward to the DHCP server. The offer message which comes back, right, will be obviously from the border. It will send a VXLAN encapsulated DHCP information, and it is able to send it to the right. It is able to send it to the right fabric edge because of that option 82, right? So the border will decapsulate that information, and using that option 82, it is able to send it to the right edge device. So once this guy gets it, and then it's obviously going to reply back again, and it's going to acknowledge and all of that. So that all of that remains the same. But the very important thing, three things: you need to configure your fabric edge to be a proxy ITR. You need to have option 82 enabled, right, on this guy, and you need to create those dummy loopbacks on your border so that your loopbacks doesn't get so that your DHCP offer don't get dropped, right? If at t is equal to 0, right, because you will not have anything redistributed from Lisp into BGP. As a result, you need to kind of have some kind of a dummy loopback over here to kind of punt the DHCP offers which come into the Lisp process. Alright guys, so that completes the whole discussion on whatever we set out to do. Just to summarize, right? We set up the whole campus fabric here, right? We did a quick introduction of the topology in the first section. We configured the underlay. Then we went about configuring the overlay with Lisp and VXLAN. We did macro segmentation using the various virtual networks. There was a small correction here, right? I had mentioned wrong subnets. I just fixed it. We also created a subnet in the global routing table as well for our infra VN. Then we also talked about intra-VN communication, that is, within the same VN, that is within the IT or within the sales. We showed how clients were able to talk to each other. We showed mobility, how mobility works. Then we went to the policy plane where we configured SGT, and we kind of showed how how we can establish trust sec, and we can kind of limit access between two different resources using SGTs. We kind of were able to ping host 1 and host 3, but we restricted SSH access, right? And the last is we talked about Fusion router, which is very important because Fusion is kind of gateway to talk to the outside world. So we initially set up the VRF, right, BGP here, and we kind of, once we did that, we showed how our individual VRFs can talk to the outside internet and to the enterprise network. We played around with the whole route leaking, right, between the global routing table and the VRF. In case of the IT VRF, we kind of gave it the full access to everything, whereas for the sales VRF, we gave it access only to the DHCP and the internet, but not the Active Directory. And finally, the third thing is we checked out the Inter-VRF communication. That is, we established communication between VRFs as well, right? If that is your use case, you can check that out. We did that using just playing around with the route targets, right? We imported and exported the route targets wherever necessary, and we were able to establish the Inter-VRF communication. And the last is we spent few minutes on talking how the DHCP flows, right? The DHCP, how DHCP process actually works in a campus fabric. The three important things, right? Configuring proxy ITR on the edges, and then having your option 82 enabled, right, to carry that extra information and help our border identify which edge to forward the DHCP packets to, and also creating those dummy loopbacks on the border. That is also very important, right? So thanks a lot for watching, and hope this series was useful. Have a good one, guys. Bye.